Yeah, good afternoon, everyone. In this presentation, in this work, what we are doing is we are looking at the reliability of creating polypyrrole based conductive cotton fabric. Okay, so we know the importance of, I mean, in the flexible electronics community, we know the importance of having electrically conductive fibers because they can be used in a lot of applications. They're breathable, and if they're conductive, they can be made into sensor applications, and other wearable devices can use them for various applications. So that is definitely an established fact. But the problem is, if you're looking at wearables, one of the key things that we have to look at, particularly from a fabric point of view, is whether they're washable or not, and what is the reliability after washing. So in this work, we are trying to see whether the conductivity of these kinds of fabrics remains post several cycles of washing. So what we did is we basically looked at many ways of creating conductive fabrics are out there. You can basically create some CNT composites with cotton strands, or graphene can be used, and so on. What we did is we basically looked at conductive polymers, in this particular case polypyrrole, to see if we can actually create some polymerization in situ so that they are actually attached to the fiber. That is one. And two, whether we can create structures that are basically then easier to fabricate in a larger area, because these kinds of if you look at other synthesis techniques, they're not very suited for very large area uniform synthesis of these kinds of fabrics. So what we did is a quick introduction. If you're not aware of this, polypyrrole looks like this. This is pyrrole structure, and you have this pi conjugation that is going around like this, and that is the one that is creating conductivity inside the polymer chain. And many ways of synthesizing it are available. I mean, we get pyrrole monomer. You can actually oxidize it to make it into a polymer chain, and various ways of doing that are available. And the interesting thing about this is that based on those methods, I mean, for example, changes in oxidant concentration or temperature or pH and everything can actually give you different properties of polypyrrole. So which is a nice tuning parameter that you have in itself. What we did is, I mean, if you look at previous works with polypyrrole, people have reported things like strain sensors have been reported. Supercapacitors have been reported on a small area, and hydrophobic surfaces have been reported as well, again on a small area. So what we want to do is, in this work, create a large area deposition or synthesis of polypyrrole fabric, and see whether it sustains after a few cycles of washing. In our previous work, which was in FLEPS 2023, what we did is we created again a small area, cotton fabric or cotton pad, and saw whether we can at least get conductivity out of it. So that has already been reported by us in our previous work. So in this work, what we are doing is we are creating. So we are using the similar, synthesis mechanism, which is this. We basically use FeCl3 as the oxidant. And it's basically called in situ liquid polymerization, because the polymerization happens in situ where the monomer itself is residing, or the monomer solution is residing, one. And two, because the oxidant is in liquid state, they typically call it that. So in this case, we are using FeCl3 as the oxidant. It basically converts into FeCl2 and oxidizes this into a polymer chain. And the synthesis looks like this. We have this cotton fabric. We basically dip it in pyrrole solution, and once we do that, we then dip it in FeCl3 solution, and wherever pyrrole is residing or has been attached on these cotton fabrics, you basically get a polymerization of it. It starts turning black in color, and after an hour, so it basically then starts looking like this. the nice thing about this is, like I said, you can create very large baths of these liquids and produce very large, structures with pyrrole attached on the surface. For example, if you're using cotton fabric, you can dip the entire cotton fabric in a large petri dish or a bowl, and then create polypyrrole on the entire surface. So it basically then looks like this. Then we dry it. Initially wash it for removing FeCl3 residues. Dry it at 80 degrees centigrade, and then you can use it for whatever you want. It's a conductive material now. It's a conductive fabric. So in this case, because we are talking about reliability of it, we did some washing cycles for it. But we can actually use it for other things as well. So one of the things that we found out is, because this cotton fabric is still a little soft, you can actually get some piezoresistivity out of it as well. So one of the ways in which, and we used it for characterizing it as well. So one of the ways in which you can actually see whether how it's behaving, like the entire structure is behaving, is, for example, if you look at the resistivity you're getting versus force. I mean, what piezoresistivity you're getting for this kind of a structure. So one of the ways in which we characterize it is, we create a crossbar architecture here. I mean, we just put conductive electrodes on the top and bottom, and then put the polypyrrole fabric in the middle. And when you basically get sort of press this, you get this kind of a curve for the piezoresistivity of this, and you can then actually look at across this structure, wherever you look at whatever points you are trying to measure, you can see what kind of curves you're getting. And again, because we are doing it for the first time, a very large area of 20 centimeters and all, we wanted to make sure that we are getting similar curves everywhere. So we looked at various points on the map, on the surface of the fabric, and figured out or saw at least that the stress strain curve or the resistance force curve is similar wherever we are looking. So that is one of the things that we looked at in this work. The other thing, like I was talking about, reliability issues, and particularly with the fabric, we then basically saw whether we can wash this cloth, and it turns out, I mean, like I said, we do an initial wash to remove FeCl3 residue. At that time, it is a little, it is hydrophobic. That has been reported anyway in literature. But if you give it a little time, some of the pores of cotton do sort of open up, and they basically it starts behaving like a normal cotton fabric after a while. So once we did that, we actually then started multiple cycles of washing, and we definitely observed that when we are washing it, its resistance definitely goes up. It starts to become more and less conductive as we keep washing it. And it is expected, because we can imagine that some of the conductive polymer strands or polymer material is getting washed away from the cotton fabric. But the interesting thing is, after certain cycles of washing, we basically sort of hit like a stability or a stable value. So this average value is actually for the last 5 washes that we have done after wash 6 to 10. We were basically able to get a very low standard deviation there. So we're getting like a stability after certain cycles of washing. So whatever could have been or had to be removed or was removed has already been removed after 5 cycles of washing, and then we can get a reasonably good or a stable structure. And then, for example, if we design for this, we can then we can claim that multiple washings after this will hopefully not really change the structure all that much. So that is what this study was about. So we figured out that after a few cycles of washing, you can actually get a reasonably stable response from this. Like I said, we basically made that matrix for a 5x5 structure, and looked at what resistances we are getting for all of those points across the entire polypyrrole fabric of 20 by 20 centimeters. And As you can see, for as fabricated one, we had a little low resistance values here. But once we did 4 washes, 5 and 10 washes, you can see that the difference between the two, started to become less significant. So we are hopeful that further washes hopefully will not really change it all that much. Because it takes a lot of time for it to dry and everything else. We're not able to do multiple cycles after this. But we are at the moment. I mean, in the same cloth, we are still trying to sort of reuse it and rewash it, and we are still measuring it, and we'll try to see whether we can report hundreds and thousands of cycles in the future. That is what we are working on right now. So and again, the other thing that we are looking at is bigger dimensions. 20 by 20 centimeters is nice. From a literature point of view, it's the highest that has been reported so far. But if you want to make a cloth or some kind of a structure out of it, it's still a long way to go. So to be able to make like t-shirt sizes and everything else, we are looking at 1 meter by 1 meter, polypyrrole covered cotton fabric, and multiple hundreds of cycles of washing is being done in my group right now. So yeah, that's all I have. Thank you so much for listening in.